make sure you're facing me, please. Make sure you have your own space on the floor that everyone can see. Okay? I am going to put up an image, and when I put up that image, I just want you to decide how many dots you see in that image. This is called quick images, and it's quick because I will flash it very quickly. Okay? So that you're aware. I'm going to start with a little bit easier one, just so that you can get started, okay? There's a lot of space over there if you just move over that way. Yep. Perfect. Yeah, just move all the way over. Perfect. Thank you for being a problem solver. All right, is everyone ready? When you have the answer, how are you going to tell me you have the answer?
Nope, what do you do? There you go.
And I call it a silent thumb. Take your thumb and keep it tight to your chest. That way it doesn't get in anyone else's way. Then we can stay in our own bubble. Silent thumb. All right, here we go. Ready? I told you it was a quick image. It's quick. Everybody close your eyes. Think about what you just saw. What about the picture helped you know how many there were? Okay, open your eyes back up. I'm going to show it again. If you think you know what it is, double check to see if you're right. If you weren't sure yet, this is your time to look at it again. Here we go. Ready? And I'll show it one last time. Here we go. Stop for just a second. I call these teacher timeouts. I just want to talk to your teacher really quick. Timeout, not in trouble. Timeout, take a break. Okay? We're just going to talk really quick and I'll be right back. You can listen to everything we say, you just have to be quiet during our teacher timeout. During these pieces, you're doing a lot of formative assessment. One of the things you're really looking for, are they utilizing the frames or the ideas in the picture, or are they utilizing a lot of counting strategies?
Okay.
It's not a bad thing if they're using a counting strategy, it's just that it tells you where they're at.
Absolutely.
So where are we at? Are we back at a stage where we have to count one-to-one directly model, or have we moved to making groups?
Perfect.
So it's just a quick formative as you roll it down.
Thank you.
Okay. How many did you think you saw? Raise your hand now, and I'm going to call on a few people. If somebody says an answer and you agree with that answer, then your hand will go down, and I'll keep moving around the room. How many did you see?
8.
You saw 8. How many did you see?
6.
6. How many did you see?
7.
7. How many did you see? 9. I'm going to stop right there. We have 6, 7, 8, and 9. And I'm going to tell you something that you're going to find really weird. This is why I said never talks with me are the best, because I'm strange. Are you ready? I'm really glad that some of you are wrong. Great work. Way to be wrong.
That's rude.
No, I'm serious. Nope. Not at all. I'm really serious. I'm glad some of you are wrong. And there's a reason for that. Number talks are not about sharing math. They're not at all. It seems like that, but that's not what they are. Number talks are about using each other as a community of people to learn math. Right now, I'm glad that some people are wrong because you're going to learn from the people who are right how they did it. You can't do that unless we have a community that knows how to share. So because of that, if you got the answer right, I cannot hear this. Yes! Because then people around you aren't feeling safe. They don't want to share. They feel like, I can't even say what I think. And I don't want to see this if you got it wrong. Oh, I hate number talks. I'm terrible at math. Because then how are we going to learn and how are we going to grow? So you right now, I'm going to tell you the answer. And when I tell you the answer, no reactions. No reactions. We're just going to be ready to share how we knew. And if you want to change your answer, you can. It's called revise. Revising your answer doesn't mean, oh, I just changed it because Joe said it was 12 and I agree with Joe. Revising means I have a reason why I changed my answer. That's why I'm going to choose to change it. Okay? So I'm going to call on a few people before I turn it over. What was your answer?
8.
8. Why did you say 8? How did you see 8? Okay, she saw 8 because she saw 5 and 3. I'm not saying she's right or wrong, but in a moment I'm going to give her a chance to look and decide if she's right or if she would choose to revise. What was your answer?
6.
How did you get 6?
Because when you did the third time, you did it a little slower.
Okay.
And then I saw 5 and 1.
He saw 5 and 1, and he got 6. Just a second. Do 5 and 3 make 8? Does 5 and 3 make 8?
Yeah.
It does. Does 5 and 1 make 6? Absolutely. So right now, their math isn't wrong. It's just how they saw the picture. And we're going to talk about that in a minute. I had 2 other answers that were out there. Who else did I call on? What was your answer?
I said,
You said 9. What did you see?
I saw 5
He saw 5 and 4. So we have 5 and 3, 5 and 4, and 5 and 1. And we had another answer. Who was our other answer? In the back, what was your answer?
I seen 4 and I seen 3.
He saw 4 and 3. So in just a minute, I'm going to turn it over. This is why number talks are so important. It is not about a right answer at all. Number talks are about what do we see and how do we know. Do 5 and 4 make 9?
Yes.
Do 5 and 3 make 8?
Yes.
Do 5 and 1 make 6?
Yes.
Do 4 and 3 make 7?
Yes.
Everyone is right, but they all saw it in a different way. So now we're going to focus on how do we see it. Again, when I turn this over, are we going to do this? Yes! Here we go. How many are on the left? 4. How many are on the right? Here's what I need to know and here's what I want to talk about. I saw a lot of people think that there were 5 on this side. Why do you think they thought it was 5? And again, I'm glad they were wrong, because we're all about to learn something right now. Why do you think they thought it was 5? No, you're fine. Keep going. You're on it. When I flipped it over, what do you notice? Oh. What's the first thing you saw when I turned this image over? What did you notice? What did you see? You saw some blank spots. Well, how do the blank spots help us? What do we notice about this whole picture? What did we notice? What did you notice? There's a lot of dots. What is this thing called? What is this called? Do you know what it's called? Yeah, I call it a 10 frame. I've heard people call it a 10 chart. This is called a 10 frame. What do we know about a 10 frame? What do we know about a 10 frame? Just tell me one thing you know about it. Oh, there are 10 squares. Do you agree with that? There are 10 squares. Are there 10 squares? There are 10 squares. What else do we know about a 10 frame? Who can add on to that? What else do you know?
That they're all boxes and each box has dots.
They're all boxes, and those boxes can have dots. What else do we know?
They're all, it's 5 in each box.
All right, here we go. This is really important. Are there 5 boxes on this side?
Yes.
Are there 5 on this side?
Yes.
I need you to turn and talk to a partner. Wait, you have to know what you're talking about. How does knowing that help us decide how many dots there are? Turn and talk to a partner. And I need you back here in 3, 2, and 1. I'm going to actually go to the back. Again, I could care less whether he was right or wrong. Okay? The reason I'm calling on him is because he was right, and I want him to help teach you guys how he got it right. What did he do? I think you used that idea of a 10 frame, didn't you? What did you notice about this picture?
That if it was 10, I did 10 minus 3, 10 minus 3 is 7.
Can someone repeat what he just said? What did he say?
He said that he got 10, but he said 10 minus 3 equals 7. So if he took away 3 dots, he would get 7.
And who can add on to that? Why did he take away 3? Why did he take away 3?
Because there are 3 squares missing.
Do you agree with that? Why do you agree?
Because it's supposed to be 7, because if there's if there was 3 dots, it would be 10, but they're missing some.
Would you like to revise your answer? So what's your answer now?
7.
And why is it 7?
Because he was right, and and I thought it was 6 because I thought I saw 5 and I couldn't, and I thought
And now how many do you see on that side?
7.
You see 7 altogether because you see 10 minus 3. So I'm going to stop you right there because I have to get going. I want to talk to your teacher just really quick, and then I'm going to move forward. One of the hardest parts about number talks in 3rd and 4th grade is that they come with so much procedural knowledge to you that trying to do them feels like that you are forcing a lot of things upon them, and that they do get disengaged because they feel like they can't access it. Number one, the thing that I need you to do a lot of is go back to quick images. Notice with this quick image, I didn't do 7 quick images, I did 1, and I really pushed them to figure out how do we share, what does that look like, how do we move that forward. In time you'll start to move that forward. It's also a great way soon to really start to relate things back to multiplication and start to see those groups. But before you even get to this, you have to really go back and push 5, 10, and 20 frames to get them to latch on to that idea. It's okay not to do a lot of images. Today we did 1 and got great conversation just from 1. So it's okay to push that. The next thing I would do would be number strings, not mental math. Because we need to give them things, again, they can latch onto and get that safe environment. Then I would go back to it.
Perfect.
3rd graders, thank you so much for having me in today. See, didn't you have a good time? Come on, you